Hello, pre-calculus students, and welcome to the continuing lesson on identities for angle sum and angle differences. And in this video, I'm going to show you how to solve this particular problem here. And it is very helpful to identify what makes this problem hard to solve. And you can see right off the bat that we have x and 5x here inside of the trig identities. And not only that, we also have differing trig identities. So we have a cosine here. So we have cosine 5x, cosine x, sine 5x, sine x. And so some of the possibilities on how to solve this is, well, we can just use cosine sum and cosine difference to break this 5x down into x. But before we do that, let's start by just getting one side equal to 0. So sine x cosine 5x minus the right side here, cosine x sine 5x equals 0. Okay. And normally at this point you would look and try to factor. So maybe you can pull out a sine out of both of these terms. Maybe you can pull a cosine out of both of these terms. But you cannot factor in this case because the angle inside of the trig function is different for each one of these. So I'll make an important note here that we cannot factor because the trig functions are different and the statements inside of the inputs for those trig functions are different as well. Cosine 5x and cosine x are not the same thing, so we cannot factor them. Same thing, sine x and sine 5x are not the same thing, so we cannot factor them either. And you can probably guess from the note that I have here, we're going to solve this by somehow collapsing this together. And so I want to bring your attention to the identities that we have for angle sum and angle differences. And so you can see here, let me zoom in, whoops. You have these identities here which are very useful, and from the previous examples you see how we go from the left side to the right side. Okay? Well, this is an example of how we can go from the right side back to the left side. So that's what collapsing really means. And so you can see that sine x cosine 5x minus cosine x sine 5x, that's really just the sign of a difference. Okay, that's just really the sign of a difference. So this is really using sign of difference. And we can use this because this expression matches up exactly with the right-hand side for the sign of a difference. So now we can collapse all this together, and what you end up getting is sine of x minus 5x equals 0. Well, that wasn't too bad, and now we just reduce this, and you get sine of negative 4x equals 0. And I can take this down a step that's even further than this. I can get negative sine of 4x equals 0, and I'm going to write my reason on this one is that sine is odd. Okay, since sine is odd, then sine of something negative is equal to negative sine of something positive. Okay. And this just makes things a little bit easier to work with. It's nothing really special. Now I can multiply both sides by negative 1, and in effect I've gotten sine 4x to equal 0. Okay. Look on the unit circle, where is sine equal to 0? Well, it's up, it's here at this point and here at this point. So we have 4x equals 0, and this is how we take the input out of the sine function, and 4x equals pi. Going a step further, we get x equals 0 because we're dividing both of these by 4, and x equals pi over 4. Now, one thing we have to be careful about is we're so used to just adding 2 pi n to this. The reason we add 2 pi n is because the period of the sine x function is 2 pi. In this case, though, just a quick note here. I'm going to circle this and make a note on the side. You have that is a horizontal shrink by 1/4. So the period is not 2 pi, it's 2 pi over 4 or pi over 2. Okay? So to be entirely correct, we have to go x equals 0 plus pi over 2n, x equals pi over 4 plus pi over 2n. Okay? And now we have a complete solution to this problem. And so two parts that we have to look out for. First is the part that allows us to even solve this problem. It's that this form here represents the right-hand side of the sign of a difference. So that allows us to collapse it down. And we do a few things here with the sign, with an odd identity, just to make it a little bit simpler, but that's really not necessary. We can probably solve it anyways. It just might take a little bit longer. And in the end, the other tricky part is we have to be careful that this right here, this function right here has a period of pi over 2, not 2 pi. So when we add the expression here, it's plus pi over 2. It's not plus 2 pi. Okay, so there's an example there that will help you to solve some of the problems on your own. And again, these things are very difficult to solve. What you can do is just keep working at it, be patient with it, and try to think through these problems. Think ahead a little bit before you start writing. Okay? And if you get stuck, there's nothing wrong with going back and trying a different method. I know it feels frustrating sometimes. We want to be able to solve a problem easily from beginning to end, but that's not how higher level math works, and that's not how any challenging problem really works. It usually takes a couple tries and a couple misfires, even for your math teachers. So keep working at it. As always, ask for help if you need it. Have a wonderful day.